Good morning, good afternoon, good evening, year 8. Here's your revision podcast for the end of year exams. Now, we're currently still learning about ecosystems at the time of recording, but it will be in your end of year exam, so it's important that you revise that. In terms of the topics, you have 4 to revise for, not the entire year, but 4 to revise for. Definitely revise climate change, that will come up in your end of year exam. Definitely revise energy. Definitely revise weather and climate, and obviously ecosystems at the end. So, in terms of climate change, obviously you need to know about global warming, the fact that the Earth's getting warmer, and the fact that we know the Earth is warming up, the ice is melting, the air is getting warmer, this means the ice is melting, this means there's more rain, this means there's more higher sea levels caused by this. Warmer climates and warmer temperatures around the world on average. True or false? Temperatures in the polar regions are set to increase by the most of anywhere in the world. This is true, okay? Because they're not going to be the warmest places in the world at the poles, but they are going to increase by the highest amount. The deserts will get hot and hotter, but the polar regions will increase by the most temperature. So global warming is going to happen. This is the Earth getting warmer, the increase in global temperature, and climate change is this longer term change in the climate of the planet. Okay, now this is mainly down to greenhouse gas increase. So what greenhouse gases traditionally do, like carbon dioxide, like methane, like nitrous oxide, like CFCs, but mainly methane and carbon dioxide, CO2, what they do is they trap the heat from the sun. The sun comes down, hits the Earth's surface, and then bounces back off into space. But what these gases do are trap it. They keep it down here in our atmosphere so it's warm enough for us, basically, which is perfect because it means it's the only planet in the solar system where we can have life, and that's why there is life here. But climate change is happening because of human actions, like, for example, burning fossil fuels, but it's also happening because of natural causes. So we studied volcanic eruptions, how that can change the climate for the warmer and the colder. So in the short term, the ash from a volcanic eruption blocks the sunlight, makes it colder. However, in the gases coming from a volcano, there's greenhouse gases in there, added to the atmosphere, makes the climate of the whole world warmer in the longer term, once obviously that has time to take effect. Then you obviously have the Milankovitch cycle. So the fact that Earth is changing in its orbit around the sun, so it gets closer and more circular. You get a warmer climate, an interglacial climate, whereas if it's more ovular and further away, we get an interglacial climate, which is what the Ice Age is. We're heading back towards glacial now, that's why it's getting... we're heading back towards interglacial now, that's why it's getting warmer. And the last one is sunspots. Spots of energy on the sun that can affect the amount of sun's heat and radiation that we get. Then revise energy. So definitely revise, the process of how we get energy. We burn things. We boil water. We burn oil. This heat then generates steam. This steam turns a turbine. This turbine turns a generator. This generator can basically be powered into electric. And then the national grid basically shares that electric with all the houses and businesses that need it. We obviously burn fossil fuels as part of that. So oil, coal and gas, but we also can use nuclear energy, which is good and bad. It can be dangerous, that's a bad thing, but it gives off no greenhouse gases, so it is technically better for the environment. That's a good thing. There's also renewable energy, so solar radiation using solar panels, for example, or water turbines. Any of these 3 things are very important. So water, tidal, sun, all those 3 things can basically last forever. That's why they're called renewable. And if you burn any plant to produce an energy, that's called a biofuel, because you're burning a living thing. Trees, wood, soil, whatever it may be. Then look at the screen right now. You can see a climate graph. You need to know what this is and what it means and how you do one. That's why we studied it 2 times in lesson. So those blue bars you can see on the screen, they are rainfall of the place. So I can just tell, without researching or revising this country, looks like Vancouver at the top, this area, that there's not very much rain in JJ in the middle, June, July, or August, but there is quite a lot of rain in December and January. If you look at the right hand side of this picture, you see the word precipitation. This axis here is the rainfall. So if I'm being more specific, in let's say October, the O at the bottom, there's around about 120 millimeters of rainfall in that month. It's a climate graph, so it shows you the average of any one year. Whereas in, let's say, July, in the middle, the second J, it looks like there's about 25 to 30 millimeters of rainfall, so a lot less. You also have, on the left-hand side of this graph, the word temperature, and then some numbers from minus 20 to 40. And the temperature on this graph is shown by a red line. So if you ever get a temperature to put in, it's important that you use the left axis or the right axis, depending on how it's labelled, and you draw the red line. So I can tell, for example, in January the temperature is around about 2 degrees Celsius on average. It gets slightly warmer in February, March, April. May, it's around about, what's that in May, about 12, 13. And then you have June, July, there's peaks. And then back down in December, back towards kind of where we are in January. So the red line is temperature. So it's important that you know how these things work. So this is a climate graph. It shows you the long-term weather patterns. Now, weather is day to day. So, for example, right now I'm looking at the sky. It's very sunny. That's the weather, because this is the day-to-day conditions. Whereas climate is more of the longer-term conditions of an area, like 30 years or more of an area. Again, excuse the music in the background, but ultimately, yeah. So we have different weather conditions. High pressure is happy weather. What I mean by that is when air falls down because high pressure forces it downwards, you get clear skies, you get calm weather, you get sunny spells. If there's no clouds, you get the sun out. Whereas low pressure, the air rises. So the air rises up because it's quite light. If the air rises, it does three things. It cools down once it gets up there. It condenses, and therefore you get clouds. So at low pressure areas, you get lousy weather, you get cloudy weather. With clouds, you often get rainy weather, wet weather. Don't forget, that's not about temperature. Temperature is not to do with pressure. Temperature is instead to do with latitude and where you are in terms of the equator. So in low pressure areas, it's lousy, it's rainy, it's stormy, windy, wet, cloudy. And then high pressure is the opposite. High pressure is not cloudy, it's clear. It's not wet or rainy, it's dry. It's clear skies. It's not stormy weather, it's calm. There's not much wind. And then make sure that you revise ecosystems as well. Don't forget, that's very important. So, what is an ecosystem? An ecosystem is a mix of living and non-living things and how they interact. That could be the soil, that could be rocks, that could be the sun. For non-living things, that's abiotic factors, and that can be plants and animals for the living things. A biome is just a large ecosystem. So rather than saying my garden, that's not a biome, but the tropical rainforest is a biome because it's across the whole planet. Okay, so tropical rainforest like the one in Brazil, or the one in Democratic Republic of Congo, or the one in Malaysia. The reason why they're there is because they are on or near the equator, and at the equator you have low pressure, and that is the conditions I just told you about: the wet, the cloudy, the windy, the stormy. And you need those conditions for a tropical rainforest, otherwise it wouldn't be a tropical rainforest. And then it's important that you also revise about, adaptations, so plants and animals adapting to areas. So in the desert, they adapt by making sure that they, for example, it's important to name animals, but a white fox, for example, in the desert has white fur to reflect the heat of the sun from the desert. In terms of a colder environment, so maybe like the tundra, for example, that's a cold biome. In the tundra, plants and animals have to deal with a couple of things. They have to deal with intense cold. Therefore, they might have certain fur. You might have polar bears having fur to make sure they try and absorb as much heat as possible. You might have other animals that have to go a long time, maybe without water or food. So they have to adapt in terms of hibernation. They have to adapt in terms of storing food in certain places for when they can have it. And we'll revise that a little bit later. But otherwise, any questions you have, please put them in the comments. I hope this helps. I'll see you again soon. Take care.